Welcome to Lesson 18, Writing, Evaluating, and Finding Equivalent Expressions with Rational Numbers. Now, this idea of expressions, real important, and how expressions are different than equations. So let's go over that a little bit right now. So what exactly is an expression? Okay, it's this term you hear over and over again, and it's hard to distinguish sometimes the difference between an expression and an equation. But here are some things that an expression can be. An expression can be a number or letter or a letter that represents a number. Okay, so these are two separate things here. It could be a number or a letter that represents a number. Okay, and examples include, see right here, x. Okay, x itself is an expression. Okay, 3. X squared. Okay, where the x in both of those cases there represents a number. All right, those are expressions. So that's this one right here. Another thing an expression could be is a product whose factors are any of the above. So, for example, 3 times 2. Okay, 4x is an expression, right? The sum, another one, last one here is a sum and or difference of the above. So 3 times 2 plus x minus 2. Okay, all of these. What do you not see in any of these expressions? You don't see an equal sign. And that's not to say that there isn't a value to an expression. Eventually there can be, and there usually is, okay, but you are not balancing a side necessarily with an expression like you are doing with equations. Okay, so with that knowledge or renewed knowledge of what an expression is, let us move on to exercise 1. Okay, so here we are at classwork, or exercise 1, and we'll go ahead and read this. Read the problem for you here. John's father asked him to compare several different cell phone plans and identify which plan will be the least expensive for the family. Use the information contained in the table below to answer the following questions. Okay, so you're going to use all of this info in this table to answer a series of questions. So you're going to do some analysis. Okay, you're going to do a little cost analysis here, which is quite a real thing, a real, truly real world application of math. Okay, is trying to choose a cell phone plan. I mean, it truly is. Okay, so right down here, here's all your information here. Didn't want to do that, but it says all members of the family may not want identical plans. Therefore, we will let X represent the number of phone lines. Okay. Y will represent the number of phone lines with unlimited texting. And then Z represent the number of phone lines with internet access. Okay. So we need to we're going to create 3 expressions here, and these expressions are going to actually kind of lay out more or less a formula that we can plug in numbers with later, okay? Because we don't know how many of the family members want such and such plan, okay? Or for example, want a phone line, want unlimited texting, or want internet access, okay? So we have X, Y, and Z to stand for those numbers. Those are our unknowns, okay? So let's go ahead. First step here would be to go ahead and write expressions for companies A, B, and C. And you can see how these work across here. Here's company A's information right here. Okay, this is what they charge for all these different services, and then B, and then C. Okay, so you can see across that they what they charge for these different services. Okay. All right. So if we are going to go ahead and write an expression, okay, for all three of these companies, let's just go ahead and I will go ahead and do company A, and you can then go ahead. I'll let you pause and go ahead and do B and C and come on back and we can check those together. Okay. So company A, if we wanted to write an expression, right away a monthly fee is going to be $70. Okay. So and you can see up here it includes 1,500 shared minutes. Okay. So with company A, we're going to pay that monthly fee, okay, which is going to be $70. All right. Now, price per phone line. Now, this right here is very one-time thing. Okay, not one time, but each month. It's a monthly fee. It doesn't vary based on the number of people who are on the service. Okay, you just pay that. Okay, it's a monthly fee. So that's $70. To that, we're going to add. Okay, now price per phone line. Okay, price per phone line. So in this case, it's 20. Let's get rid of that one. It's $20 per phone line. And we said that X was going to represent the number of phone lines, okay? And we can see we have that noted there, X, okay? So what we're going to do, we're going to put there is we're going to go ahead and put 20X. And this is how you show that, and again, this is how we express that part of this expression, because we have 20X. So for every one person, which is going to be represented by X, we will multiply that times 20, okay? And then to that, we're going to add the price per line for unlimited texting, and that is 15. And we said we are going to actually use Y to represent those who want unlimited texting. Get rid of that there. Okay, Y. And then finally, we're going to add the price per line for internet access, okay, and that as well in this case is 15, and that is going to be Z, okay, so Z, because Z is standing, is representing the number of phone lines with internet access, okay. So now with this expression, what we can do, which is really neat, is we can actually then start plugging, once we have some numbers, we can start plugging in plugging in values for X, values for Y, values for Z. Once we find out within the family how many want the different services. Okay. All right. So what I'd like you to do right now then is to go ahead and use the information for company B and company C that you can see in the table, and go ahead and create expressions for B and for C, and come on back and compare it to what I have. Okay, so hopefully you have expressions that match these here. Company B, 90, one time that monthly fee, plus 15X plus 10Y plus 20Z. Okay, and they all come from the table. Now, company C is very interesting because they charge a higher monthly fee, $200, but they only charge per phone line, which would be represented as 10X. Okay, so what they do is they include unlimited texting automatically, and included the monthly fee as well as internet access. Okay, and this does happen very often in real life, that companies will offer packages such as this higher monthly fee, but with more added services. So what we're going to do now is we're actually going to go ahead and plug these. We're going to go ahead and use these expressions to make some decisions here and decide which, in a different number of scenarios, which company would offer the best rate, would be the best value. Okay, so on the next page, you will see two scenarios. We have A and B, and there'll be one more, actually C, on the other side. Flip the page, but anyway, here's your direction here. So using the expressions above, and those are the expressions that we've already come to. Find the cost to the family of each company's phone plan if and right here for this scenario, if 4 people want a phone line, 4 people want unlimited texting, and the family needs 2 internet lines. Okay, so our key numbers here is we have 4, 4, and 2. Okay, 4, 4, and 2. Now we're going to go ahead and analyze what the cost for what each company would be charging for these services. Okay, let me go ahead. I'm going to do company A. It's all a matter of plugging in numbers for our unknowns or our variables. Okay, so with company A, of course, we're going to bring down the 70 because that's always going to stay the same. But now we're going to add 20 times 4 because we know that 4 people want a phone line, okay? And then we're going to add, and then plus 15 times 4 because 4 people want unlimited texting, and that's what Y is standing for. And then we need 2 internet lines, so that's going to be plus 15 times 2, okay? And you notice I'm actually, when I'm substituting the variable with a number, I'm putting that number in parentheses, which just denotes the fact that I am going to be multiplying. Kind of keeps these keeps them separate too, keeps the functions separate. Okay. All right. Then if I continue on, I just go ahead and do my multiplication. So now I have 70 again plus 20 times 4, which is 80, plus 15 times 4, which is 60. Plus 15 times 2, which is 30. And then if I add all these up, 150, 210, $240. Okay, so company A would be charging $240. Okay, for this plan. All right. So okay, so let's go ahead and should we go ahead and do B together, or why don't I just have you pause right now, go ahead and do B and C in this scenario, and see when you come back we'll look at what I have too. Okay, so here's what I came up with here with company B. As you can see, again, just plugging in, taking the value. These values here again, the 4, and the 2, and plugging those in where I have X, Y, and Z respectively. Okay, and again, these are the expressions that we came up with initially. Okay, just so you remember that that's where these came from. Okay, those are our expressions for each company. And yeah, just plugging in again 4, 4, and 2. And doing just like I did with company A, working those out. And for company B, I got $230. Company C, $240. Okay, so if we're going to answer this question here, which cell phone company should John's family use and why? In this case, and again, we're assuming that everybody's service is comparable, just as good as the other. Okay, because there are other we would call intangibles. Things that are not necessarily related just to price, just quality, service, etc. But right now we're just making this decision solely based on cost. Okay, so if we just do that based on cost, we're going to say company B because it is less expensive. Okay, and that's it. All right, so you're getting the same services for less money, but again, the quality of those services, that's to be seen. Okay, so let's go ahead and move on to B. Okay, so scenario B. In scenario B, 4 people want a phone line. 4 people want a phone line. 4 people want unlimited texting, and all 4 people want internet lines, which seems a bit silly, but for our purposes here, we'll go ahead and forego the silliness, okay? Or look past the silliness, I should say. So, anyway, go ahead and plug those numbers in, plug those values, the 4, and the 4, for X, Y, and Z, respectively. And use the expressions. I've just rewritten the expressions up here first. Just continue to do that. And go ahead and solve right now for the three companies and answer the question, which cell company should John's family use? Of course, we're just looking for the cheapest price. Okay, so go ahead and pause, do that, and come back. Okay, so plugging in 4, 4, and 4 for X, Y, and Z yielded me these numbers here. $270 for company A, $270 for company B, $240 for company C. Therefore, which cell phone company should John's family use? C. Cheaper. Okay, there we go. Cheaper. So in this case, this higher monthly fee of $200 worked out to be a good price, actually saving $30 over the others. Okay? All right, and if you didn't come up with these numbers, just go back and check your numbers. Again, a very simple process, and just the idea of plugging in 4, 4, and 4, because that's where these come from, 4, 4, and 4 for X, Y, and Z, and we'll yield those prices. Okay, so let's move on to C. Okay, so here's scenario C. 2 people want a phone line. 2 people want unlimited texting. And the family needs 2 internet lines. Okay, so let's go ahead and figure that one out and see who gives us our best value. Okay, so with the 2, 2, 2 scenario, 2 phone lines, 2 unlimited textings, and 2 internet lines, here's what we've come up with. And again, just to see, here's where I am plugging in all of those 2's, just to make sure everyone is following along. Okay, in this case I only need 1, 2 with company C because they have that higher monthly rate and they just charge for phone lines. Okay, but it didn't work out for company C in this case. It was actually company A worked out to be the cheapest alternative. Okay, in this case, all right, $170. Okie dokie. Okay, so here in exercise 2, you guys are going to get a little practice with actually devising or coming up with an expression to represent a situation. Okay, so and here is the overall situation. Here is 3 friends went to the movies. Okay, each purchased a medium-sized popcorn for P dollars and a small soft drink for S dollars. Okay, and again we're using now, as you can see, we need the numbers here because we need three friends. P dollars. Okay, so P is going to stand for the dollars for popcorn. Okay, and then S dollars right here. If S is going to stand for the soft drink. Okay, and we're going to actually be able to. What I want you to do right now for this first one here, A, is write the expression, reading right here, the expression that represents the total amount of money in dollars the 3 friends spent at the concession stand. Okay, so just going to write a simple expression that you could use to plug in for any number of friends. Okay. In this case, we are going to need this for 3 friends. Okay, so go ahead and pause and see what you could put together. Again, it's an expression; it's not an equation. There's no equal sign. Okay, we're just writing an expression that can actually be used with numerical values to actually come up with totals. Okay, so go ahead and pause and. Okay, so here's what I came up with here. And again, I need my number. In this case, it's 3 friends we're trying to solve for. So I need my 3, and I've written my 3 right here. And of course, that ties back to that. Now, in parentheses, since they're all getting the same thing, they each purchased the medium-sized popcorn and soft drink, okay, I can go ahead and put P plus S right in a parentheses, okay, parentheses. And this is the preferred way to write this expression. Now, this P, again, doesn't stand for the number of popcorns, because that is actually taken care of here, but it is the popcorn dollars, what the popcorn cost, okay? Because that we don't quite know yet. Well, we will in problem B, as you can see, okay? And then the S stands for the soft drink dollars, okay, how much it cost. Okay, so 3P plus S. I'm going to write that again, because that's looking kind of messy there now. 3P plus S. This is my my expression. Okay, so let's just go ahead and just move on to that next one. As you can see there, let's just go to B. And it says, if the concession stand charges $6.50 for the popcorn and $4 for a small soft drink, how much did the three friends spend on their refreshments all together? Okay, so this is what we want. We want all together. Okay, so again, the question is, how much did the three friends spend on their refreshments all together? And here you have your value for P and S in the expression. So go ahead and plug that in, and let's come on back and see what you got. Okay, so here's what I end up with, again, first starting with my expression, the expression that we created in part A, and then going ahead and plugging in my $6.50 here, which was my P, popcorn dollars, then my $4 here for my soft drink dollars, which was my S, and if I go ahead again and just remembering the Pemdas idea, I'm going to do those things in parentheses first, okay? Parentheses, so I will go ahead and put that together. $6.50 plus $4, okay? That would be $10.50, okay? Which is right here. So still 3 times $10.50, and then my final answer is $31.50. Before we move on to exercise 3 and then on to our closing, I just wanted to just to look at this 3P plus S problem with the the popcorn and the soda and the three friends, and just show you how you might have actually played this out. I went ahead and solved it, and I solved it one way. I mean, there are alternate ways. So I just wanted to just respect this idea that there are other ways that this could have been solved. Again, coming to the exactly same answer, but just to show you. So, firstly, pretty much with each of them, well, at least these first three, we would have went ahead and plugged in the $6.50 and the $4 for the P and the S, because those were the prices of the popcorn and the soda, respectively. Okay, so that okay, plus 4. Actually, why don't we just go ahead and just leave this one for now? It's something that's a little bit different, so we'll let that one be for now. But as a second step, what you might have done, what I did actually, is I went ahead and just did the parenthetical part of it right there, and got that out of the way, the $6.50 plus the $4. But what you could have done is you could have went ahead and distributed. Okay, you could have actually distributed. You could have gone 3 times $6.50 plus, and I'm not sure, maybe some of you did do this. Again, good practice to get into, okay, working with that distributive property. And in another one, you might have just maybe done the same as what I did in the first scenario, okay, and the same thing. So, as you can see right here, we just, these two did the parenthetical part first, okay, just went ahead and put these together, because they were everything is going to be multiplied by 3 anyway. In this case, though, this middle scenario here, we went ahead, we could have gone ahead and just distributed that way. Okay. Now with this one, of course, with this first one, we're pretty much done. You're just multiplying that times 3 times 1050, and you get 3150. Okay. With the distributive right here, we would have to actually come up with here. This is 1950. Okay, because that's 3 times 650, and then plus again plus $12. Okay, and then we would add those two together and gotten our 3150 again. Same answer, just a little bit differently. This distributive way or distributive process might be helpful or more helpful in other situations. Now with this other one, with the end one, what somebody might have done, again, we've talked about taking mixed numbers and numbers with decimals and splitting them apart, so you could have, in a sense, gone 3 times 10 plus 50 cents, okay, which then would have equaled 30 plus $1.50, which would have equaled 31.50. And again, these are ways that you might have done this or might have solved this. Okay, for my money, in this case, this is the most efficient. I can see that this might have its applications as well at times. Okay, that last scenario, not so much, but again, it's available, and the answers are the same for each of those. Now, this fourth scenario that I avoided, just because I was really because I was running out of room there, is what you could have done, but probably the least efficient of all, was to actually turn this into an addition problem. Okay, P plus S plus P plus S plus P plus S. Okay, and here we go. We got 650 plus 4 plus 650 plus 4 plus 650 plus 4. Okay, and then of course these are all 1050 plus 1050 plus 1050. Add those all together and 3150. So you could have indeed done all this without actually doing any multiplying. Okay, because we know that multiplication is just repeated addition. But if you can see, this, for example, looks extremely much more efficient than this. Okay, so you make up your mind, but I would, if I were you, try to find the most efficient way, but also a way that includes or involves steps, okay, which show that you are able to apply different mathematical properties and processes along the way. Okay, here's exercise 3, and one thing I did notice here on my page on the screen, and also your page in the binder, I think it looks like the directions are missing. Okay, so boy oh boy, if I were, I don't know, take a little deciphering to figure out what to do here, but I'm going to go ahead and explain it to you, and I'll go ahead and do number 1 here. Let's go ahead and we'll just do this number 1 together, and this way I can, to serve as a model or an example for you, and then you can, I'd like you to go ahead and do 2 and 3 on your own and come back and check them. But let's go ahead and just look at this. So the idea, what we're going to do here, what you're going to do is you're going to complete the table below by writing equivalent expressions, okay? Equivalent expressions to the given expression and evaluating each expression, each expression with the given values. Okay, so we are going to, well, let's go ahead and let's look at the example, because that's the best way. Now in this example, first of all, they're telling you that x is equal to 2 and y is equal to -1. Okay, so that means these are these are the values you are going to plug in for x and y respectively, just like we did in the preceding problems with the popcorn cost, for example, and the small soda cost, okay, or soft drink cost, all right? Now, the expression that they are giving you, the initial expression, the first expression is this one right here, okay? For x plus 2y, okay? So again, it looks in this terms, we're going to put, we have like maybe 4 people, okay, and then we're going to multiply that by maybe each of them, the x, maybe each of them got a popcorn, and then each of them got 2 Milky Ways or something. I don't know why I said Milky Way, but I did. Anyway, so this is the initial expression, is this one right here, okay? Going to solve that one, all right, and if you do solve that one, you see we have 4, and then we're plugging in here. Now we're plugging in, for the x, we're plugging in 2, that's right there, okay, plus 2, which is there, and then we're going to plug in the negative 1 right there for the y, okay? So these two right here, I don't know what to highlight this in. Should get different highlighter color. I don't quite know how to do that. Okay, so this right here, this one, and this number, these values, these are the values that are go along with these over here, okay? So we are taking x and y over here. When you're asked to evaluate over here, that means you need to look at this expression, you're to use the expression that they give you, and then you're going to plug in these values, okay? And again, I kind of eradicated these values here with my highlighter, but anyway, so we're going to plug in 2 where we see x and negative 1 where we see y in the expression, okay? So that's what we've done. That's what we've done there, okay, in that step. Now, in the next step, of course, if you go ahead and add, you multiply 2 times negative 1, you get negative 2, and if you add that to 2, which is all in this right here, you end up with 0, which you see shown in the next step right there is 0. Okay, oops, nothing. You get 0 there. And then 4 times 0 is, of course, 0. So the value of this expression evaluated using these values here is equal to 0. Okay? And that's going to be the case for each of these, okay? Because the expression, all the expressions here that you're going to write here and here, they are all equivalent, okay? That means they're all equal the same, okay? They're all going to yield the same result, okay? Which is the 0 and the 0. But they've been written differently. I am not exactly sure why this is seen as a good activity, but we'll do it nonetheless, okay? Because it does show you a few things. It shows that an expression does not have to just be written one certain way, okay? So, for example, what they've done here in this second part, okay, in the second one, here's an equivalent. So this expression here, 4x plus 8y, is equivalent to this one here. And you can see what they've done, if you look real closely. They've actually just distributed the two amounts, the two values in the parentheses. So they've gone and multiplied 4 times x, and that gives you 4x, and then they multiplied 4 times 2y, which gives you the 8y, okay? So what they've done is they've distributed this that first expression and come up with that second expression, which equal the same. They're the same. So again, with that second expression, what you are doing is you are plugging in values again. Here is our 2, which is our x value, and here is our negative 1, which is our y value. And then if we go ahead and evaluate those, 4 times 2 is 8. 8 times negative 1 is negative 8. You add those two right there, and you end up with 0, as we did the first one, okay? Now, that one's valuable. I think this one's valuable right here just because it shows you how, I mean, it actually makes it quite a bit easier when you distribute, okay? Now the second one, the last one, the third one, just kind of has you doing something else. So what it does is it's taking, because this initial expression over here, and I'm going to just erase this just because it looks kind of messy now, so just so we can use that. This initial expression, we have 4x right here, so they put that right there, okay? But then they have 4 times 2y, so you have that actually twice, so you have 4y and 4y, which is the same as 8y, which is over here, okay? So what they're doing now is they're getting away, in a sense, getting away from multiplication and just showing this as a series of additions here, okay? So 4x plus 4y plus 4y, this expression here, again, is equivalent to 4x plus 8y, which was there, that one, and then also 4x plus 2y, which was over there. Equivalent. They're all the same. Therefore, of course, they're going to give us the same zero answer. All right. But again, like we did with the other one, we're plugging in. Plug in 2 for the x. Plug in -1 wherever you see a negative, and wherever you see a y, and go ahead and evaluate. 4 times 2 is the 8 there, and then 4 times -1 is -4, and -4. Add all those together, and you end up with 0 again. Okay. So hopefully that's not too confusing. And just in case it is, and you're still feeling a little bit confused by it, I'm going to go ahead and do number 1 with you right now. Okay, so number 1, what they're giving you now is they're giving you your first expression, which is this right here, and that is again a number, an integer outside of a parenthetical expression. We are going to evaluate this expression using only one variable, which is nice, which is y equals 1. So wherever you see y, you're going to plug in 1. Okay? So if we go ahead and evaluate this, then that's going to be 5. And then 3 stays the same, there's nothing to attach to it, minus 4 times 1. Okay? All in parentheses. Now that's where, because that's where this is, the y equals 1, therefore I'm going to plug in the 1 for where I see y, okay? If I do the parenthetical stuff, I just go 5, and then 3 minus 4, which is going to be -1, okay? And that's this in the middle there is where I'm getting that -1 from. I'm going 3 minus 4, okay? If I wanted to, actually maybe I should do one more step anyway. Let's just do that. What don't I want to just show you that one. Okay, so again 5, and then 3 minus 4, because I've just done the multiplication. I multiplied 4 times 1, okay? So then it's going to be 5, and then if I complete what's inside of here, 3 minus 4 is actually -1, okay? And then 5 times -1 is -5, okay? Now, this is going to be the answer. This -5 is going to be the answer for each of these expressions, equivalent expressions as we go across. So if you remember with the example here, this second expression was just the first expression distributed, okay? So what we'll do then is if we're going to distribute this expression here, we're going to go 5 times 3, okay, which is 15. And then we're going to subtract minus 5 times 4y, which is going to be 20y, okay? All right, so 15 minus 20y is the first expression distributed, but this is going to yield the same answer. It is equivalent to this one, okay? It's an equivalent expression, all right? It's going to yield the same answer when you plug in the values, and you could probably see that right away, okay? So if I go ahead and plug in, here's my y here, I'm going to plug in a 1 for my y, so I'm going to go 15 minus 20 times 1, Okay, so then I'm going to go 15 minus 20, because 20 times 1 is 20. Then I know 15 minus 20 is going to give me a negative 5, and I was successful there with that one. Okay? All right? And now the last one, again, really, really, not so bad now, but in the numbers 2 and 3, it's going to get a little obnoxious. But in this one, not so bad. If we were to write this as a series of addition or subtractions, we would have 15. Okay, because that is our 5 times 3. All right, and then we have y. We have minus 10y. Minus 10y. Okay, not exactly sure where that comes from, but I am taking this out of the book here. So you know what I'm thinking. I'm going to make a decision right here. I'm going to go ahead and just because I don't feel very comfortable with this one, I want to just eradicate this. If you just eradicate this last column, I'm sorry. And hopefully I don't learn to regret this. But if it does come up that it was necessary, we can get back to it again. But honestly, it's just really it gets messier and messier. Actually, number 2 is really messy. So I'm going to go ahead and just take that one off. All right. Anyway, so hopefully you did number, column 1 and column 2, and you got your negative 5 and your negative 5. And again, I just think it's real valuable to do the distribution between the first expression and then to get the second expression. Again, these are all equivalent expressions. Okay, so let's go ahead and move down to, actually, why don't you go ahead and do 2 and 3, and again, ignore that third column for now, okay? I hope I don't learn to regret it. But, yeah, and there's going to be some, I'm going to move this up here. You can see there's, it's not tricky, okay? Let's not say it's tricky at all. I guess the only reason you'll need column 3 here is actually to work backwards from this one. But I don't like that either. So I'm going to go ahead and give you this. So let's just go ahead and we're plugging in 8x minus 6y. Is going to be your first expression here, okay? And again, let's just ignore this here. I'm sorry. We're just going to do that. I made that decision, okay? All right. So again, maybe tricky. Again, you have 2 values here, 2 variables for 2, 2 variables for 3, and pay attention. You have negative variables, okay? Negative, and you have a fractional variable there in number 3. But let's go ahead. I have confidence in you. See what you can do with this. Go ahead and create your create your one other equivalent expression here and here, and then go ahead and solve both problems. Okay. Okay. So here's number 2. Number 2 here we started from with this expression negative 3x plus 12y. Okay. Going and plugging in, therefore plugging in 5 for my x and negative 2 for my y. Just go ahead and plug in. So therefore I have negative 3 times 5, okay, because that's where I got that from over here, the value 8. 5 plus 12 times a negative 2, and again that came from here, okay, the negative 2. Just go ahead and do the multiplication, and negative 3 times 5 is going to give me negative 15. Again, we're using our knowledge of multiplying integers. Plus, then we're going to do plus here, and then we're going to plus this expression. 12 times negative 2 gave us a negative 24, and again I put that in parentheses here to to keep it a summing problem or keeping an addition problem. And then if I go ahead and add 2 negatives, I know I get a negative. Therefore, I get negative 39. Okay, negative 39. And again, that'll be the same over here as well, which makes me happy. But let's go ahead and see what they did here. What they had intended for you to do here is that now you moved away from an expression that was already distributed, and now you're going to turn it into a parenthetical situation, which is just the opposite of what we did the first 2 examples example, and then number 1, okay? So in this case, if you're going to do that, if you're going to create a parenthetical expression from a distributed, you want to look at the two variables, or the coefficients, the numbers that come in front of the variables, which were the 3 and the 12, and you want to find something, or find a factor that works for both of those, okay? And that factor, of course, would be greatest common factor is the 3. Therefore, I put the 3 here. This is probably the more complicated task here of all of these, but you're going to go ahead, again, and I'm not sure if you did 3 already, but if you did 3 and you didn't do it correctly, you can go back and do it again after this. But you can see you have the same situation here where you have a distributed expression already, and if you want to go ahead and then do this one over again, then you're going to create a parenthetical expression over here. Okay, so after we finish this one, if you can go ahead and do that again if you missed this idea. Okay, because with my already distributed expression again, which is right here, okay, it's already been distributed. I want to put it back in parentheses. I'm just trying to create an equivalent expression here. I'm trying to make some relations between the two. So I'm going to find again, I'm repeating myself here, but I'm going to try to find the greatest common factor of this 3 and this 12. These are called my coefficients, okay? They come before my variable. And in that case, the greatest common factor is 3. And I put that here, and I don't put it as a negative. I put it as a positive, okay? I put it as a positive. Let's just get that out of there. And it's going to be 3. Now, inside the parentheses is when I will apply my negativity if I need to, okay? And I do here because I need a negative x, because that's going to then make this come true, the negative 3x part, okay? And then I need a 4y, which is going to make this part true, the 12y, because 3 times 4y, 3 times 4y here, this is going to equal 12y. Okay. Now I go ahead and do my plugging in. So once I have created my equivalent expression here, I can go ahead and plug in, and you can see I plug in my negative 5 where I have an x up top, and in the expression I plug in a negative 2 here. Do my work. Negative 5 stays the same here. 4 times a negative 2 is a negative 8. Okay, so actually I should probably put parentheses around that, and then inside the parentheses, just to keep those separate, because again I want to keep this as a sum. So then if I'm going to sum, I'm going to add negative 5 plus negative 8, I get negative 13. And then I do my multiplication, 3 here times my negative 13 is negative 39, which is the same as that negative 39. Okay? So you can pause here if you'd like to right now and do number 3 over again if you feel like you've learned something new here about going from this expression to a new equivalent expression here. So go ahead and do that and then come on back. Okay, so this is really kind of a nice, hopefully a gentle introduction to how crazy some of these things can get, okay, or can look, and they seem sometimes so difficult to work with, but hopefully you guys will get this and learn to enjoy it as much as I do. Anyway, here we go. So if I'm going to evaluate the first expression that I gave you before, 8x minus 6y, okay, right here. If I'm going to evaluate, I'm going to use this, my values of negative 1/2 for x, 1 for y. And again, these fractions are not going away. They are sticking around. So work with them, get used to them. Yeah, and hopefully they're not going to trip you up. So if I go ahead again and plug in negative 1/2 for x, 1 for y, excuse me, I just continue to solve. 8 times negative 1/2 is negative 4. 6 times 1 is, or negative 6 times 1 is negative 6. And then I've changed this to an addition problem here. I could have done it actually up here as well. but that's okay. I won't bother now. But anyway, then if you add -4 and -6, of course, you get -10, all right? That's my expression's value. That's it evaluated. So now if I go ahead and take this, and hopefully you redid this if you had done it incorrectly, and if I go ahead and take my 8x minus 6y and kind of send it back to its parenthetical state, okay, I would come up with this because, and hopefully you guys know where I got that too, and maybe you got that too. It was the GCF, or the greatest common factor, okay, greatest common factor coming in handy now, of my 8 and 6, these two coefficients here, okay. So then 2 times 4x is the same as 8x, and then 2 times negative 3y is the same as this minus 6y here, okay? And then if I go ahead, after I have my equivalent expression right here, just go ahead and plug in my values, and plug in my -1/2 for my x, my 1 for my y. So now I have 4 times -1/2 minus 3 times 1. Down here, I will go ahead and continue. My 2 remains to stay outside the parentheses, waiting its turn. Now I have 4 times -1/2 is -2. That's that value, plus a -3, because that's -3 times 1. -2 plus -3 is -5. And then I go ahead and do my multiplication. 2 times -5 is -10. Okay? Lots of steps, lots of work, but well worth it in the end, don't you think? Well, I sure hope so. Okay, so we're going to go ahead and wrap this up right now. If you have questions about this, please do not hesitate to email or give me a call. I could send you your own personal video of some step-by-step stuff, so you don't have to feel left behind or confused by this. All right, well, I hope you enjoyed this lesson. Honestly, I think for many children, despite what you may be thinking now, this part of algebra is actually the most fun. It's just so satisfying, I think, for many, and for me personally, to be able to take some values for variables such as x and y, plug them in, and come to an answer. Very, very useful in life. In real life, we will see that in coming lessons. Okay, so hopefully you enjoy it, or you'll start to enjoy it, or you'll learn to enjoy it by the end of the year. So here's our lesson summary here. An expression. We talked about expressions today again. Expression. Oh, didn't want to do that part. I wanted to do it with a highlighter. An expression is a number or letter. Okay, it can be a number or letter, or letter, which can be raised to a whole number exponent. Okay, like x squared, for example. It can also be a product whose factors are any one of the entities described above, and it could also be a sum or difference. Okay, and we saw those different examples in this lesson. Well, actually, we didn't see any exponential numbers in this lesson. Okay, that's a little bit adds another level of complication to everything, so that'll come in the future. To evaluate an expression, and this is something you're going to see a lot. Evaluate an expression. Okay, and evaluate an expression. You replace, or I say plug in, each variable with its corresponding numerical value. Okay, so you're going to replace each variable with a corresponding numerical value, which has to be given to you. As we saw in our problems, it would say, x equals 2, y equals -1. Okay, evaluate using those values. So now, using order of operations, the expression can be written as a single numerical value. So what you're doing, you are writing that expression as a single numerical value, and that's what you want to get down to. And that, in the future, you will see, is not always the case. And if it's not the case, then something has gone awry. Okay, order of operations is something that hopefully you have seen before. If not, many have come to know the acronym Pemdas. okay, Pemdas, which stands for, and actually I'll end this lesson with one slide with all the Pemdas expressions written on them, so you can actually just pause it and write them yourself, but I'll just say them here out loud. But P stands for, and if you want to say it along with me, you can, parentheses. E is exponents. M is multiplication. D stands for division. A stands for addition. And S stands for subtraction. These two generally are, you can switch them around. It could have been Pemdasa, but Pemdas just sounds a lot nicer, a lot easier on the tongue. Okay, and again, like I said, the last slide in this lesson will have those written out. If you want to pause it there and write those down in a notepad somewhere. Okay, yeah, and the last point here is when numbers are substituted into all the letters in an expression and the results are the same, then the expressions are equivalent. Okay, and we saw that in that last activity we did. We created equivalent expressions, again, just to show how like there are equivalent fractions and decimals, there are also equivalent expressions which will yield the same value, the same single numerical value, despite the fact that they look differently. And again, we use the properties of mathematics, the properties of addition, properties of multiplication to create those equivalent expressions. Okay? Okay, and as promised, here's the last slide with the order of operations written out. You can see the acronym is PEMDAS, P-E-M-D-A-S. Repeat that over and over to yourself in your sleep and even during the day. Make a little song out of it if you can. But yeah, PEMDAS, and again, it stands for parentheses. And when we talk about order of operations, what we are saying is in which order do you do these things? So you're going to have equations and expressions that have all kinds of operations in them. There's going to be exponential stuff like maybe x squared. You're going to have parentheses like you saw in these the problems in this lesson. Multiplication, division, addition, subtraction. You're going to have some expressions or equations that have all of these components, every single one in there. Okay. The most important thing is that you stick with the order of operations. You do parentheses. Everything that's in a parentheses, take care of that first. Okay, get that out of the way. That needs to be done because it's been combined together for a very, very important reason. Therefore, it needs to be done first. Okay, those parentheses need to be taken care of. Anything that has an exponent attached to it, like a square or a cube or something to the fourth power, etc., that needs to be done after parentheses. Now, that might be the first thing to do if you don't have anything parenthetical in there. Next, as a rule, multiplication, then division, addition, and subtraction, which I said are interchangeable, but not interchangeable, but could be done in different orders. But they are the last. They are the last on the operation scale. Okay, they are done at the very end. Okay. Alrighty. So I hope you enjoyed this lesson, lesson 18, and go ahead and do your problem set, your exit ticket, and let me know if you need anything at all.